Yeah, sorry. Yeah, it's okay now. Right. So I'm going to talk about distributed deep learning for image processing. So as the workshop is, this FDP is mainly on machine learning and deep learning for different emerging areas. So I'm going to talk about how that distributed deep learning can be used for image processing. Okay. So I think this is the one which I have taken from this deep learning, a crash course from YouTube. So what is the location of that deep learning when you compare with science? So when you see this artificial intelligence, which is part of science, and then machine learning is part of artificial intelligence, in the same way, deep learning is a kind of machine learning and all other stuff. I think mostly other speakers might be talking about the details of all these things, machine learning and deep learning. But now here in this session, I'm going to talk about how deep learning can be used for image processing, that too the concept of distributed deep learning. And at the end of the session, I'm going to share 2 3 papers, general papers, where we started working in this particular domain. And this is the traditional computer programming, where when we give data and a program as input to the computer, we are going to get the output. But when you come start thinking about machine learning, so data and output are input to the computer, and program that is well defined, well formulated program is going to be the output, which we call it as model. I think all of you might be knowing it, but I'm not discussing much about the machine learning and deep learning. Okay, so this is the introduction for that machine learning. Ultimately, once the model is ready, from then onwards, we will be start using this model whenever you want to test for any test data. You want to go for testing of any test data. And generally, what do you mean by learning? So learning is essential for unknown environments, and learning is useful, and learning modifies the decision making process. So for this, when you say whether it is machine learning or human learning or something, some other learning, ultimately the target of learning is these three. So as the machine is doing this task, then we call it as this machine learning aspect in that. And ultimately, so same thing, its definition, whatever I have given is from this particular diagram, is a branch of artificial intelligence which allows the computers to start thinking by itself based on the data that is given to it. Okay, and this is the textbook definition by the Tom Mitchell. And what is that? How to define the intelligence, and from that, just you go through it. Ultimately, the target of this entire thing is what? Machines try to mimic the human actions and their behavior. So this is the intention of your entire machine learning or deep learning. As a person, when you said you started learning something from your school days, so after a few days, you are equipped with uh, some knowledge in that particular domain. From then onwards, if anything you see which is related to that particular domain, now you are going to say whether it is true or false based on the given input. So when I say that you got the knowledge, I can say that you are having an efficient model with you to discriminate the things which you see in your day-to-day life. So that is the target of your entire machine learning. And then with respect to deep learning, then these are the different types of learnings: supervised, unsupervised, reinforcement learning, and self-supervised learning. Then in these four kinds of learnings, so these are the different algorithms or different aspects that can be discussed. And generally, with respect to image processing, we concentrated only on these neural networks, how these neural networks are used for image processing in distributed nature. Similarly, this is support vector machines also we have worked, but other models for image processing we never tried and we never worked with that. And these are unsupervised and reinforcement and self-supervised. As we are concentrating only on image processing, that's why I'm so specific about only these two in our entire discussion. Now, before going into that, first of all, as our target is to go for distributed deep learning for image processing. So I may be giving almost like a minutes or so, I'll be discussing about image processing and how it can be used for the distributed, like deep learning, and how what I mean by distributed here. So this is how I'm going to explain this 1 hour session, 1.5 hour session. Right, when you go to image, these are the synonyms. Okay, so if I give you one hard copy of a photograph, and let us assume that it is having some red color in the corner part. I'm talking about hard copy, no physical copy, nothing. So when I have given it like this copy, and if I ask to make this red color into green color, how will you do it actually? And yeah, it is an interactive session only. Please, you can respond even in between if you wish. Otherwise, you can even type in the chat box. Otherwise, even instead of you asking, even if I ask a kid who is second standard or say first standard or second standard kid, you also can do this. How will do that? How he will do that? Hmm. Yeah, how will you make this red color into green color? This is the hard printed copy.
Green sketch will apply on it, sir.
Yes, that's it. Then you will be asking the computer to do it. That's it. That is nothing but your entire image processing. Then how do we ask the computer to do it? Then we need to instruct the computer, okay, if it is red in color, okay, you take a green sketch and you make this as green. For that, we write the programs. Is it right or not? Exactly in the same way, we'll be looking into how to process any other kind of things which are part of this particular photo. Whatever that human being is doing, then we'll be asking the computer to do it. Okay, for that we are studying this. What is image and what do you mean by processing it? Then how to give the instructions to the computer so that computer will be doing on behalf of us. That is the entire image processing. Now, when you do it for one computer, it is okay. But when you are making the instructions for so many computers parallelly to do a specific task, then we call it as distributed image processing. And image processing, when you consider the image processing before 2012 was something, and after 2012 it is something now, because of this machine learning and deep learning part. Actually, we work in content-based image retrieval and object detection and some other things which are like related to image processing. Before 2012, all are known as traditional image processing algorithms. They are just will be processing the pixels in the given array and doing it. But after this machine learning, deep learning started, no, so they started using new kinds of algorithms which are by this one, and accuracy has changed drastically. So before like 2012, whatever the algorithm you consider, most probably will say that accuracy is 80% or so. But from after 2012 onwards, as people have started using this machine learning and deep learning aspects into image processing, the CBR has improved to 95% and even more than 95%. Because even we got the results, and we have some algorithms for the traditional processing, and we have some algorithms by using deep learning algorithms in it, and we ourselves got the results showing that okay, those are 80 and these are 95% and even more than that. That's why if you want to go up and publish any paper in machine like image processing related this, so without deep learning, almost these days nobody is accepting the papers, because there is a mechanism and there is a procedure to get 95 accuracy. Still, if you say that I have improved from 80 to 82 or 82 to 85% algorithm I have, then what is the use of that 85% improved algorithm when there are some algorithms which are already giving 95? You try to look into this and try to make it close to 100. That is going to be the good contribution these days. Okay, now we'll see. Now, as I'm talking about image, photo, and picture, they are synonyms. And we just now we saw that how we will say that converting this red color into green color. For that we need a digital photo. Okay, and these are known as traditional photos, that is normal photos. So around 25 years back, if you see, when there was no digital image, then what were the kinds of images, photos that we have is based on the reels. If you use black and white reel, we use it to get black and white photo, or people use it to use color reel. So they use it to get color photo by developing that reel in the dark rooms. Okay, I think all of you might be knowing this, or otherwise just this was the situation around 25-30 years back. But now after that, as the digital era started, we are able to represent the image by using some digits. Okay, so what are those digits? Based on that, we got three kinds of digital photos. But here, based on the reel, we are deciding whether it is black and white photo or color photo. But now, based kind of numbers that you use, based on that, we are telling whether it is black and gray photo means that black and white, whichever we are calling, and binary photo or color photo. But in all these cases, the image is going to be represented by using some digits. Yeah, can you tell me what do you mean by digit? What are different digits? Yeah, you can type in chat box. Zero one, okay. 01 are digits. Then any other digits? Only two digits we have. Yeah, please, you tell one or two answers, then I'll explain. Yeah, 0 to 9, very good. Yeah. Yeah, 0 to 9, they are decimal digits, very good. Then 0 to 1 are binary, okay. Then any other system do you know? Octal, yeah. Octal, what are the digits in octal? 0 to
7.
Okay. Then can you tell me what are the digits in base 4? Actually, binary means we know base 2. Decimal means base 10. Octal means base 8. Can you tell me what could be the numbers in base 4? Yeah, 0 to 3. Very good. 0, 1, 2, 3. Similarly, base 9, 0 to 8. Very good. So, generally, as we are from computer science background, every time we feel like these are the only bases. But even base 4 is also valid, base 9 is also valid, base 19 also is also valid. Okay, but as a computer system uses 0, 10, 8 and even base 16. That's why we may be thinking only about this. Okay, right. Ultimately, whatever the base that you consider, there we are using some numbers. That's it. We don't have anything else in any of these bases. So when you use only two numbers, 0 and 1, only two kinds of numbers, or generally 0 and 255, this is also one kind, we'll see it. Only two numbers to represent your whole image, then we call it as binary digital image or digital binary image. By chance, if you use 0 to some x value, then we call it as gray level image or monochrome image or intensity image, which we are day-to-day life, we are calling it as black and white photo. Actually, whatever black and white photo that is, you are telling me that is not black and white photo. That is known as gray image, monochrome or intensity image. And what is this max? Any idea?
255, sir.
Why 255? Is it your
Because we
lucky
are
number?
using 8 bits to represent each pixel.
Yeah, very good. So that 255 is not fixed actually. It depends on the kind of software that you are using. If your software is supporting 8 bits to store each pixel. And once again, what is pixel? Actually, what are the synonyms of photo? Photo, picture, or image. Then when I said that, okay, now this is your digital photo. Actually, inside the computer, this entire digital photo is represented as a two-dimensional array. That's it. That's why generally I tell even an 8th class student who knows some programming, and if he knows what is two-dimensional array and for loops and if conditions, he also can start working with image processing. Really, you don't require any extra knowledge to start working with the image processing. It is simply a two-dimensional array. As I said, it is a binary image. Obviously, all these blacks are represented. The first row contains all zeros. Then 0, 0 and 1, 1, 1, 1. Wherever there is white, I'm saying it is 1 and 0. Now, as each one is what actually 0 is what? Is it an element of this image or not? And next 0 is the next element of the image. And next 0 is the next element of the image. If somewhere if you have 1, this also known as an element of the photo or the element of the picture, or this is an element of image. So by making the picture and the other word element, they made the word pixel. That's it. That is the story behind that word pixel. Now, as you, whenever I say pixel, pixel is nothing but an element of the image. Obviously, an element is nothing but a number here. Obviously, when you want to store this element in the computer, you need memory. And when you say it is memory, then you need some bytes. When you say you need some bytes, it is nothing but you need some bits. Now, based on this, if you say that your computer is making or supporting 4 bits to represent each pixel, then with 4 bits we know what is the minimum value with 4 bits and what is the maximum value.
0.
0, 0, yeah, 0, 0, 0 is the minimum value and all ones is the maximum value. So all ones means it is 15 and 0. That means in the whole array you can have 0 to 15 as the numbers in this array. 0, always 0 is considered as the darkest pixel and 15 is considered as the brightest pixel. By chance, if your software is supporting 8 bits to represent each pixel, then the minimum is 0 and maximum is 255. But as of now, most of the softwares which we work, they support 8 bits to represent each pixel. That's why mostly you may be thinking that it is 0 to 255, but this is not always true. But mostly it is true. Okay. So then obviously here we are having 0 to 15. By chance, if I say that we are having only 0 to 15 numbers. Now, can you tell me? Okay, right. That is gray level image. Now we'll go to this. Yeah. Now, what is the digital image now? A digital image is nothing but a two-dimensional array. If this array contains zeros or ones, then we call it as binary image. If this array contains 0 to some x value, then we call it as gray level image. Now we'll see what do you mean by processing of it. Now, as it is simply a two-dimensional array, now I'm asking you to make these zeros as ones and ones as 0. Can you write a program so that I can say that I'm asking you to make that white as black and black as white. That is my requirement. Obviously, as a human, what you do, you take 2 sketch pens and initially you start making this all black as white and this white as black. Same thing, now you need to ask the computer to do it. So can you write a simple 2 lines of code to make it zeros as ones and ones as 0? What is the coding for this? For I equal to 0, I less than row, then I plus plus. For j equal to 0, j less than column, j plus plus. Okay, then this is an array with this a of ij equal to 0, then a of ij equal to 1, else, okay, else what? A of ij equal to 0. If 0 means 1, obviously else means the other, what is the else component? 1, 1 means 0, that's it. Now I can say that you know image processing. Is there any difficulty? Only 2 lines of code, even a first year student can write a code for this. You need not tell that it is image and all, just you give him an array and ask him to make ones as zeros and zeros as ones. But after that, just by using that IM show or something, we can display that original array and the updated array. But here, as you are doing it in A, that means there is no point, there is no chance to display original image and this one. So for that reason, what I do is that I'm replacing this in another array. Then if I display A here, then I'm getting the original image. If I display B here, I'm going to get the processed image. So that is all about your image processing. Only processing a two-dimensional array. Processing in the sense, just you will be given with some steps, which we call it as algorithm. So how big the algorithm may be or how complicated it may be, you are simply working with a two-dimensional array and giving one more array. You take either you say image processing with deep learning, image processing with machine learning, image processing with distributed machine learning, distributed deep learning, or distributed architecture. To say image processing means simply processing a two-dimensional array. There is nothing in this whole image processing. You keep that in mind. Right now, if you go to gray level, that means you know how to process binary images. If you know how to handle the 3 kinds of images, your entire study in image processing consists of some algorithms where they tell that, okay, you do this first, do next, do this, like that. Even if it is 1000 steps, all those 1000 steps are meant for looking into the contents of this two-dimensional array. Right. Now, when you consider this gray level image, and as I said, by chance, if you are assuming that it is supporting 8 bits to represent each pixel, can you tell me what are the values from this part to this part in the first row? They are towards 0 or towards 255?
Towards zeros.
Yeah, towards 0. So I can say 0, maybe 0 or 1. Okay, they are very close. And the human eye is not in a position to distinguish 0 to 255. That's why we have to rely on this digital image processing. Okay, by chance if 0 shade and 1 shade, and if your computer is supporting 255 shades, then surely as a human eye you can't distinguish between the shade 0 and shade 1, but for computer 0 is different and 1 is different. Okay, so let us assume that they're all nearer to 0. Yeah, can you tell me what are the values nearer to this in the forehead? Approximate values. Around, okay, I'll say 50. Okay, now this area, is it brighter than this 50 or darker than 50?
Brighter than 2.
Okay, then obviously I may be saying it is around 250 or something like that. Okay, right. Now, like this entire image, this array consists of numbers. Now I'm asking you to make her hair, which is black in color, into white. Can you write a program for this? Just the way in which you have written here for Lincoln image, same thing you can do for this also. What you will be writing? If A of ij equal to 0, then B of ij equal to 255. Okay, initially we assume like that. So I'm writing just B of ij equal to 255. Then wherever there is 0 in this array, okay, initially I'm copying the whole content of A into B. Then in the B I'm modifying. Why I need to do it in B? If I do it in A, I can't see the original photo. I want you to display both original and processed. But in the hard copy, when you do it, there is no chance to see original. Only you will be seeing only processed photo. But here, when it's a soft copy, so we can copy paste 100 times, and all the 100 versions we can see. 255. Now in this case, what happens here? So wherever there is a 0, then it is going to become 255. Now let us assume that this area is also zeros. Then this also becomes 255. But what is my question actually? you need to make only her hair into white. So there the actual image processing, difficulty of image processing starts. For that, we have to write the algorithm how to really detect the hair part in the given image. And whenever you say that you are making the program, it is not to say that that program works only for this image. Then nobody in the world will use your program. Whatever may be the photo that you give, so hair part has to be made as white. Even if I give 1,000 photos, in all the 1,000 photos, your program should be in a position to make hair part into white. So there you will be writing a program to identify the hair part. There the actual difficulty starts. But of course, don't look into such kind of difficulty task now. Just whether you can handle this array or not is the intention to discuss this now. Right. Now, if you go to the color image, now just when you consider these two images internally, how those
75% means at least it should be 7 programs, ma'am. 5 it is completely. No, there are 9 only, no? Hmm. Achha.
is audible.
Sir, you can carry on.
Yeah. Right. Now, okay, when you go and see the components of this, then I said no, this is a binary image. It is simply a two-dimensional array. And this is gray level image, which consists of some numbers. Here I assumed that 0 to, okay, 15, let us assume. So whatever the numbers that you are going to have in this array are nothing but 0 to 15. Now, if you go to color image, then we have to see how the color image is represented inside the computer and what do you mean by processing a color image. Tell me, what are the primary colors? Any idea? Okay, red, green and blue are the primary colors. Very good. But if you see your color cartridge, color printer cartridge, so do you ever seen RGB? Color cartridge, what are the 3 cartridges that you have in the color cartridges? Total there are 4 colors in color cartridge. Are they RGB or something else? If they are something else, then you tell me the reason. If they are RGB, okay, we'll accept it. I think most of you might have seen color printer, no? But have you ever observed the cartridge there? Actually, they are not RGB, but what are they? Anybody is typing? Yeah, HSI, no. HSI is another color model which we use in color, like in image processing, but in the color printer I am asking. HSI white, no. It's not HSI white. CMYK. Yeah, please you observe any cartridge in the world which is part of your the color printer, it is CMYK but not RGB, because RGB are the primary colors. You are true, but these are based on wavelength, that is light, that is for viewing purpose. But CMY, cyan, magenta and yellow, they are also known as primary colors, but for printing. And RGB are known as additive colors, and these are known as subtractive colors, but I have forgotten the reason why they are known as like that. Okay. So both are primary colors, but these are primary colors with respect to viewing purpose, but CMY are the primary colors with respect to printing. That's why we never have RGB colors as part of printer. Okay, but of course here, as we are talking about this color image processing, here it is represented with RGB components only. Okay, now when I say color image, it is made up of 3 two-dimensional arrays. Cyan, magenta, yellow and black. Yes. Now when you go with color image representation inside the computer, it is 3 two-dimensional arrays. One is red component, then green and blue. But even though these are like 3 two-dimensional arrays, ultimately they are 2D arrays, that you keep in mind. So you are looking into red component, green component, blue component, and accordingly you will be processing. For example, I have given you one red rectangle like this, which is full red. Okay. And as I said that when you see this inside the computer, it is represented with 3 arrays. This is known as red, this is green, and this is blue. And each component once again requires you just 8 bits to represent, and here also 8 bits, and here also 8 bits. That means the possible values in the first component are 0 to 255, here also 0 to 255, here also 0 to 255. Now, when I open this red rectangle, then as it is pure red, I'll be seeing all 255s in this image, in this component, and all zeros here. Then here also all zeros. Okay. Now I'm asking you to process this and get me same rectangle with green field. Can you tell me what I need to do for those 3 arrays? If you tell it, then I can say that you can look into color image processing also. There is nothing here now. What modifications I need to do for these 3 arrays? After that, I'm doing some modification and combining it into one array. Okay, one unit. When I display that one unit, I'm going to see the processed image, which is nothing but converting this red rectangle into green rectangle. Now you tell me what modifications I need to do for these 3 arrays. Second array should be 255. Very good. So I'm making this whole 0 cells 255s. Then second array 255. What about first one? Okay, very good. So first one I'll be making everything as 0, and of course third one 0 already did 0. Now when I combine these 3 into a single unit which we called as color image, then obviously when you display those 3 after combining, you will be getting it. That's it. Can you write a code for this? Simply considering this array and make all 0s as 255 and here all 255 as 0 and combine only 2 lines of code. Then you can say that you know color image processing also. Okay, whether you do traditional image processing or you do with deep learning models or whatever it may be, in all these models, they will look into the pixel values and accordingly, they will process it. That's why you must aware of the fundamental representation of image. So whatever is the image that you consider, only we are having only these 3 kinds: binary image, where the 2-dimensional array contains only 2 kinds of values. Gray level image, it is a 2-dimensional array, contains 0 to x values, and color image, it contains 3 two-dimensional arrays, each one with 0 to x, 0 to x, and 0 to x. That's it. Now, whatever the algorithm that you look now, just you will be working with these numbers and getting some output, some outcome of this. And what is the output or outcome? Generally, I say in all the 3 cases that we have seen so far, input is image and output is image. In first case, you are able to display the black and white, the zeros as made into white and zeros as made as ones and one has made into 0, and you have displayed 2 images. And in the second image, and I ask you to make this black color into white, then also you have displayed original image and this one. And even in color image also you did. But by chance, I have given you one photograph, and here it is like this. Then I'm asking you to write an algorithm and display the number of persons in this one. Will you display one more image or you will be displaying the answer as 2? And because no, I'm expecting you to tell me the number of persons in the given image. I'm expecting the answer as 2. I am not expecting you to display one more image, then ask me to start counting. Then in that case, I need not give the problem to you. Okay, as I'm expecting this, that means ultimately what you need to understand here is that image processing does not mean that input is image, output is also image. It need not be every time. So input is image, that is true every time. Output is an image, or output can be some statistics or something, need not be an image. Right? So your entire image processing now, you see, it is nothing but looking into the numbers in this two-dimensional array and do something for those numbers and get the result. Do you now you tell me, is there any difficulty in start working with image processing? Nothing. Only provided if you know two-dimensional array and how to work with the arrays, if you know, that is more than sufficient to start working with image processing. Now, why we started with the distributed image processing? And actually, as we are think most of you are from computer science background, I think all of you know this subject, theory of computation. Is it true? All of you know it or not? Okay, right. I think surely you know it. Then in that there is a concept known as pumping lemma. Actually, around 5 years back when I started teaching TOC here at NIT Warangal, so I looked into this pumping lemma and explained the theorem. But even today also, when somebody asks me to explain the theorem, I'm a bit in confusion about the explanation of the pumping lemma. So what I did that is that I explained it to the students in the class, and after that I asked them, okay, and I asked them to submit an assignment by explaining that theorem, and that explanation need to be recorded in a video. Recorded video. And what is the advantage of this recorded video? So those around 4 or 5 years back, no? So when you start explaining it to somebody with your face in the video and so on like that, obviously you will be getting more grip on that particular topic. You also see here, if I ask to write something, directly you can take from a book and directly copy paste or directly write with your hand, even whether you understand it or not, it doesn't matter. You can write 100 pages of assignment. But when I say that you need to explain it to and that explanation need to be recorded, surely I can say that only with some more understanding, then only you can start doing it. So there, when I have given this, no, so everybody has submitted the assignment almost like for 3 years like that I did it. So around 300 videos I have. But some students, when I did like that, what they have done is that by using video cut software, they have pasted their friend's video into this. Okay, so initially they are visible here. Okay, first 2 minutes their face is visible. After that, as the camera is focused on to the pen and paper, then another student he also given his assignment for 2 minutes. After that, he cut and pasted to it, and it became this much length of video. Then, as there are so many videos, I want to find out the plagiarism, video plagiarism for that. Okay, then as we know video, how video is different from image? Is there any relationship between image and video? Yes. If you can show 32 photos per second, whatever the way that you want to choose, you can choose it. If you are able to show 32 photos per second, then we'll say that we are seeing video. So this is general, but of course, plus or minus some X value will be there. Some people say 32 frames, and even some softwares they can display even 40 frames and even 20 frames. So if 20 frames means less quality and 40 means even more quality like that. But ultimately, video is nothing but collection of photos. As we want to process those many videos, around 130 videos per 1 year, so I felt it is very difficult to handle those many videos to start processing. because I need to check who has copied from which video. Then I started looking into distributed processing of video. Like, of course, my intention is video, but first I started with distributed processing of images. For that, okay, this is all I'm skipping now. Okay, right. So for that, I started around 5 years back. The big data has started, of course, started long back, but for me, it was new during that time, around 5 years back. Then I want to use that big data technologies to process the image. When you see this big data, which is meant for distributed processing, the two main components of big data are storage and other one is processing. That's it. If you really say you understand these two, whatever the textbook or whatever the literature that you see related to big data, they talk about storage and processing. Now I'll tell you why you need to go for storage and processing here. For example, you are having 1 liter water bottle. Okay. Now how much you can store with 1 liter water bottle? How much water you can store? Maximum? Yeah. With 1 liter water bottle, what is the maximum water that we can store? 1 liter. Okay. Now let us assume that one of your friend, who is your best friend, he is having 1.5 liter water with him, and because of some reason, he is requesting you to store that 1.5 liter with you for 2 days. After 2 days, he will come back and take that water with him. Then how will you handle the situation? No image processing, nothing. As a general situation, how will you handle this one? You have only 1 liter water bottle and your best friend is asking you to keep that 1.5 liter water with you. How will you handle the situation? You can't say no. Yeah, please, anyone? Okay, so right, as there is no response, myself I'm telling. So generally, people say that you want to buy a 2 liter water bottle. Okay, good, very good, because he is your best friend. That's why you are not hesitating to buy a bottle. You bought it. Okay, somehow you are managed with this 1.5 liter. After a few days, that same friend came with 2.5 liters now. But as of now, you are having only 2 liter water bottle. Now, one more time, let us assume that you bought 5 liter water bottle now. Okay, he is your best friend, you are able to do it. Next time, after a few days, he came with 5.5 liter. Then you may be vexed with this one. Even though he is your best friend, every day is coming with something, and you are supposed to spend some money for it. Okay, otherwise you assume that you don't have money now. So, and here, this is the point that you need to understand. He told you to store it only for 2 days. It is not permanent storage. Now you realized the importance of this one. Then how will you do it now? Now you realized that instead of buying it, then you may be borrowing a bottle from your neighbor and taking it for 2 days, and you are storing this 5.5 liter, and after 2 days anyhow you know that your friend is coming back and taking his water, then you are giving water to him and returning back that water bottle to your neighbor. That's it. That is what the big data concept is doing. Okay, now when you say that you have 5 liter water bottle, and what is the capacity of the bottle that you are taking from your neighbor? Let us assume that it is 2 liter. And at the same time, you also assume that you made those two by using straw. The straw in the sense that what we use for our coconut drinking. By using that straw, you connected these two. Then by making that connection, I'm calling it as a cluster. Can I call it as a cluster or not? It is a single unit. Now, what is the total capacity of this single unit now? 7 liters. Like this, how many bottles I can connect to my cluster? So this is my original bottle. I am using so many straws to connect different bottles. I have taken one more bottle from my another neighbor, then 10-liter bottles from somebody else, and 1 liter from somebody else, then 250 ml bottle from somebody else. So like that, I am connecting all this. Okay, by making like this, I can say that I made a cluster of bottles. In computer terminology with respect to big data, we'll say we made a cluster of computers. By making this cluster, what you are getting? You are getting extra storage. That what is the total storage? So the sum of all the individual bottles. Initially, as you are having limited storage, now by making a cluster, that too temporarily, you are making one unit where you can store more than what you were able to store previously. So that is how the data storage problem is solved. That means instead of this one, I will be saying that I have computer here, then I am connecting all these computers by using a software which we call as Hadoop as of now. By doing so, I'm making a cluster. Actually, in our college, we made a cluster of 116 computers. So all these computers are contributing in storage and as well as processing. So that is how we are able to handle that big data processing, or otherwise I call it as distributed processing. As I am looking into images, that's why I call it as distributed image processing. Okay, so storage part is how we resolve. Then processing. So if you say that you understand these two examples, whatever the book that you study now, most probably I can say that you can follow all the big data technology. So processing, when it comes to processing, yeah, that is assume that you are a faculty and this is your HOD. And he has given you 100 image processing scripts, answer scripts, and he is asking you to correct these papers in 2 hours. But we know that it is not possible to complete all the papers in 2 hours, but because of some reason, he is asking you to do it in 2 hours. Then how will you handle the situation now? See, it means correct me, like you should do it perfectly. It is not like simply putting some random marks or so. So how will you do this in 2 hours? And we know that we are not Rajnikant, where he can correct the papers with 2 hands, 2 legs, something like that. But we are not like that. Yeah, how will you handle the situation? So is my voice is audible? Hello? Hello? Ah, okay, right. Thank you. And by chance, if nobody responded, because here only screen is visible, so I'm not sure whether it is. Fine. Yeah, how will you handle the situation? Generally, people say that they take the help from somebody. Who is it somebody? Can I call my kid who is studying the 7th class to start correcting image processing papers? No. Then whom I should call? I can call my other colleagues. So for example, if you are an assistant professor, yeah, please. Anuradha, you have any doubt? Yeah, okay. Right. As this is the case, I'm taking the help of one assistant professor. Can you take the help of associate professor? Yes, he is also your close friend like that, and he also ready to help. And can you ask a professor for help? Yes, because he don't have any ego problem and he is ready to help. And this assistant professor, he taught the subject for 2 times. Associate professor, same subject, he taught it for 10 times. And professor means he taught it for 20 times. And now I'm going to take the help of a student who got 100 out of 100 in the last semester. So I'm calling them, and when they said that they are ready to help, then I can say that I made a cluster of persons for processing. And now, as there are 100 papers, how many papers I can give it to these persons? Is it 25, 25, 25, or what else? Because I am giving it like this: 10, 20, okay, 50. Okay, there is okay, assistant professor, no? Okay, 20, 30, 40, and 10. Now total 100. Why discrimination? Please, you try to tell me. If you tell it, then almost I can say that you understand the whole processing mechanism in big data. Why more number of papers are given to professor? Depends on experience. Yes, experience in the sense his processing power is more. Okay, that's it. Exactly in the same way, when you start connecting these computers to make it as a cluster of computers, then I can have a computer with 2 GB RAM. I can have with 8 GB RAM and 16 GB and 2 GB and 48 GB and 200 GB and 2000 GB. Something. All can be part of my cluster, but minimum I am saying 2 GB. Why 2 GB? Because here I am telling what is the minimum qualification here, not my kid. Why it is not my kid can be part of my the correction process? Because he don't have any knowledge in this. What is the minimum? Who is having minimum knowledge here? The student. Because just now he studied, he got 100 out of 100. The same way, when you start connecting these computers by using Hadoop, okay, we'll say that minimum requirement for the computer is 2 GB. Now I made a cluster of computers, and here I made a cluster of faculty members. In the previously, I said that I made a cluster of water bottles. Water bottles are for storage, and this faculty are for processing. Now, but when you consider computers, so computer is having both storage and as well as processing power, or only storage? Computers are used for storing and as well as for processing. Very good. So that's why you don't require two different clusters, one for storage and one for processing. Then when you made a cluster of computers like this, then I can say that you can use these computers for storing where you were not able to store with your single system, and you can process bit faster. So this is very, very important. So by processing, you are not getting any extra advantage. The only extra advantage that you are getting is faster. See here, in the paper correction also, for example, there are 4 people correcting the papers. Okay, and you are here, and this is your HOD, and these 4 are your this thing. Let us assume that roll number 501. This answer script went to this particular second person. And let us assume that he got 20 marks. Okay, has he got 20 marks there, then if the student should not come and complain that if it is suppose if it was done by somebody else, I might have got 22, something like that. So if he says like that, then our entire example is wrong. So either it is corrected by you, this person, or somebody else in your cluster, the marks must be same. Then how do we guarantee that it is going to be same? As a faculty, we know that we use scheme of evaluation. When everybody follow the scheme of evaluation exactly the way in which it is given, then whether it is corrected by you, person 1 or person 2 or person 3, it doesn't matter. But only time is varying. But ultimately the result is going to be same. When you consider the cluster of computers, when for some processing, when data is given to any of the computers here, the answer must be same irrespective of the computer number. Okay, so that is going to be the advantage of this. But what is the yeah, that should be the case. What is the advantage that we are getting here by doing so? we are doing it by faster way. That's why I'm telling this. Ultimately, what you are doing here, as your HOD has given you HOD has given 100 papers. You are able to do it in 2 hours. Otherwise, if you start doing by yourself, okay, then it may take 2 days. But only thing that you are doing here is that faster in the sense. Yeah. Any questions up to this now? Then I will show you what we have done based on this. Dr. Vibhulesh, do you have anything to discuss? Right. Now, when we started working with this big image data processing, that means ultimately we have processed images with distributed environment. Okay, the kind of processing is varying, whether it is traditional image processing algorithms or deep learning based image processing algorithms. This is the content of this lecture, distributed deep learning for image processing, right? Then when you consider this big data, actually, this one you see, I think all of you know, might be knowing about this big data, no? Yeah, if you see the technical definition, it says that the data may be having the characteristics like velocity, variety, and volume. Now, my simple question is that, yeah. The difference between can and must. Now you see, for example, if you have a co-education college, okay, there, now you tell me co-education means both boys and girls must be there or both boys and girls can be there. Can be, yes, very good. So don't think that it is must. In the same way, when you say that big data, people say that the data can have characteristics as velocity, variety, volume. But nobody say that the data must have these 3 characteristics. So that is very finer observation that you need to understand. Because when I'm talking about big image data processing, so here I don't have velocity component, I don't have even variety component. I have only volume component of this big data. Volume in the sense, once again, which can't be handled by one computer, because that 1 liter water bottle, now you are supposed to handle 1.5 liter. That means somebody has given you more volume than what you can handle. Now how to handle it? So that's why only volume characteristic of the data is considered in our entire processing. Then generally when you go this variety component, no, people say that you can have structured data, unstructured data, and semi-structured data. Structured data means your database tables. And even in our processing, we never worked with any database tables. Only we worked with images and videos. So that's why this diagram I had drawn it and show the relationship between image processing and big data. Okay. So this is the diagram in image processing and big data combined into this one. Yeah. Okay. So these are the different scenarios that you can consider. More number of images here. And here a single image is very big in nature. What do you mean by this big in nature? For example, if you consider this image, the size of this image, dimension of this image is approximately 5000 by 5000. But when I kept it here on the in this PPT, nobody is getting the feeling of real 5000 by 5000. But now I'll open this by using some software, that is your traditional paint. Then you can see the real feeling of that. Yeah, now you please see here the same image I've opened with this paint. But if I want to see the whole content of this image, I need to use this scroll bar here. Please you observe it here. And even towards down also I am using that scrolling. Okay, now this is a 5000 by 5000 image. Okay, but actually we ourselves have created by using Adobe Photoshop an image of dimension 32,000 cross 32,000. Then you can really try to imagine what is going to be the dimension of that when it is 32,000 by 32,000. Okay, and we are written the code by using these distributed systems to handle such kind of images. This is also one aspect of big image data processing we are talking, that is with respect to dimension. And when you go with any single image, whatever that you download from internet, maximum it might be in KB in size, or at most I can say MBs. But there are some images whose size with respect to memory is 1.74 GB size is created by us, and even 5 GB, even 4 GB images which we have downloaded from the image from the internet. When you want to process this image, obviously our single system is not supporting the processing of this. So for this we used that same cluster whichever we made to process the images. Okay, now for this we have used Hadoop as the software, and I'm skipping all this. This is the cluster with 116 systems. One is known as master node, and these are known as slave nodes. And this is the cluster configuration which we made in our college, NIT Warangal, and these are the systems configuration, processors and CPUs in that. And here with this, we could able to create 28.3 terabyte of storage, HDFS, Hadoop Distributed File System. But actually, none of the systems in our college are more than 1 TB hard disk. But now with the help of this cluster, we could able to make 123 1 TB. And we initially we processed text data. After that, we started working with these images to process. So these are the MapReduce jobs related to that. And we processed like 5,11,308 images for the task of CBIR. This is about traditional image processing. And these are the different times it has taken to complete. And as I told now, a single image is very big in with respect to dimension. 69,000 into 20,000, which we got from the internet. And this is 2 lakh by 1 lakh. So these are the existing images with different dimensions. And we have taken them and processed with the same cluster. What is the use of that cluster? When you do that with single system, it takes more time. To reduce the time, we have distributed the thing to multiple computers. And then that is all about traditional image processing. Then the machine learning component of image processing starts when you start using this SVM. The feature extraction part is the traditional processing. Then the classification part we have done with SVM. Then after that, the deep learning features, deep CNNs are existing, and as we started using them, and deep CNNs are used for feature extraction, and SVM is used for classification. And as the next category, by using transfer learning, we did that. And the next category is the whole deep CNN model is used for extraction and as well as for classification. So by using this, we did some work on COVID images, and somehow Okay, it got accepted in one Scopus Index journal. Okay, we are happy for that. Now, as the last case, and this is one of the things that we have done by using this one. So pedestrian detection, and this is the whole work that we have done based on this pedestrian detection using deep CNN models and image retrieval basic model. And here internally we have multiple algorithms to do this image processing, image retrieval by using deep learning. Okay, and these are the different things. And the last category, the present trend is that use deep CNN features and handcrafted features both together to make either for classification or object detection and so on. So we started working in this. And when you go with this combination and all, then the actual distributed deep learning has started. Okay, ultimately the deep learning model, as we have discussed in the beginning very lightly, about you need to get the model by giving some training. The training is given parallelly at different computers. That is the concept of the distributed deep learning. Okay, and for this we have used these technologies, and these are the papers can say that you also can start looking into this. So parallelizing backpropagation neural network by using MapReduce and Spark is one paper which we referred for this content. Of course, as of now, I have not included any results which are related to this distributed. Still, we are working in this that particular thing. And another paper, distributed computing for training neural networks for image guided diagnostic. Okay, here it is about diagnostic applications, but based on our application, you can change it. Okay, so I think with this, I'll stop here. Then actually at 3 o'clock, I have one more class. That's why I can't extend any further this thing. Okay, so thank you. Thank you for giving an opportunity to deliver this content. Yeah, if you have any doubt, please, anything to ask, you can ask now. Whatever I have covered, just to give some basic idea, like, okay, there is a concept of distributed deep learning for image processing. You have to explore it. When it's one and a half hour, I think this is the maximum I can say that I can cover.
Sir, thank you, sir. Thank you very much.
Yeah. So
Yeah, Shanti madam, please.
Thank you, sir. Thank you so much for the wonderful session, sir. You have given future directions in image processing in the area of deep learning. Thank you so much, sir.
Okay, madam. Thank you. Okay, then I am leaving the meeting. Is it okay?
Yes, sir. Yes, sir. Thank you very much, sir. Thank you.
Okay.
Now, Sunit Gupta, sir. Sunit Gupta, sir. Am I audible, sir?
एक मिनट नेहा ऑनलाइन रहो डॉक्टर Oblesius, yes please.
Yes, yes, sir. Yes, sir.
Just we start in 2 minutes. Okay.
Okay, sir. No problem. No problem. So, I request all the participants, if you have any doubts regarding previous session, please mail me or text in a chat box. I will mail you the answers which are collected from the speaker. So next speaker, Dr. Sunit Gupta ji from Bennett University, Noida, Uttar Pradesh. Sir given so many talks. So I request all the participants, don't miss this one. And I am expecting some interaction with the participants. Anyone interested to interact, or if you want to give any suggestions? I request all the participants, any suggestions regarding this FDP, anything? Feedback form already I pasted in chat box. feedback form already I pasted. Day 2 session 3 feedback form already I pasted in chat box. Please fill the feedback form. Yeah, Navya madam, again I sent a feedback form. Also check it out.
Yes, hello. Good afternoon.
Yeah, good afternoon, sir. Good afternoon. Sir, are you ready, sir?
Yes, I'm ready. So,
Now I request Shanti madam to introduce today's today's session speaker, Dr. Sunit Gupta ji from Bennett University. Now I request Shanti madam, please introduce the speaker.
Good afternoon, sir. Good afternoon, all the participants. I welcome Dr. Sunil Kumar Gupta, sir, for the 3-day faculty development program on applications of machine learning and data science in the emerging areas. Welcome, sir. It's my privilege to introduce Mr. Sunil Gupta, sir. He has done his PhD in computer science at Indian Institute of Technology, Dhanabad, and he's NVIDIA DLA Ambassador for Computer Vision. Mr. Sunil Kumar Gupta is a professor in the Department of Computer Science Engineering at Bennett University, Noida. His current research interests are wireless sensor network, Internet of Things, natural language processing, and brain-computer interaction. Presently, Dr. Gupta is working on a wireless sensor network-based project funded by Department of Science and Technology, Uttar Pradesh. Dr. Gupta is a reviewer of many international journals, that is computer network, wireless personal communication, information science, IEEE transactions, etc. Dr. Gupta is also part of a project funded by the Royal Academy of Science, London, entitled with Leading India.ai. Under this project, Dr. Gupta has organized 50 plus workshops on deep learning and Internet of Things. He has more than 30 research articles, authored 2 books, and 2 book chapters in his account. Thank you, sir. We are glad to have you here today, sir. Over to you, sir, please.
okay. So thank you, Professor, for a nice introduction. And just we start the session. So actually, my topic is hands-on on machine learning technique. Okay. So today, just I'll introduce with the artificial neural network, and then we will go with a lab on artificial neural network. And basically, this artificial neural network is also one of the technique which comes under the machine learning, and you can utilize this algorithm or this technique for the classification means logistic regression or linear regression. Okay, so just we have a couple of slides I have. So just we start with the presentation and then we come to the lab part. Okay, so I think because this FDP is totally based on advanced techniques, technology in big data machine learning. So hope all of you are also means all of you know about the neural network. Okay, and just we discuss about a little bit about the ANN and then we go for the lab. So here just you can see that one image is there. Okay, so this image is basically of artificial neural network. So first I would like to share one information that this artificial neural network is a kind of replica of our mind. Okay, or you can say the human brain. So in human brain, just we see millions of neurons are there and all the neurons are connected with each other. So just some of the signals will pass to the neuron. Okay, so in our body, different sensors are there. Sensors like ear, eyes, nose, skin, these are the sensors. So basically, these sensors are sensing the environment, collecting the data, and sending the signal to the brain, and brain process that information and generates some kind of output. So similarly, means artificial neural network, similar kind of means behavior of artificial neural network is also very similar to the brain. So basically in a ANN, one layer is there that is known as input layer. Okay, and at the last output layer is there, and between input and output some other layers are there. That layers are known as hidden layer. And just in input layer, a user can pass the data. Data is processed in between in the hidden layers, and it will generate the output. So here just you can see it is one of the most popular algorithm nowadays. Okay, it's a part of machine learning, and this algorithm is one of the most popular algorithm. So this algorithm is not new. Here just you can see in 1970s it was invented, and the research community has started working on it. But there was some restriction with the ANN or neural network, you can say that. What are the restriction? So with respect to ANN, huge computational power is required. If you do not have the sufficient computational power, then you will not get the good results. So that's why in 80s to 2005 or 6, yes, neural network exists, artificial neural network exists, but research community has not put lots of attention on this technique due to the computational restriction. But after introduction of the NVIDIA GPU, suddenly this area got a huge popularity. Yes, hello, hello. Okay, sorry. Okay, just wait. I'll. Sorry, sorry for that. I was in impression that already I shared. But anyway, sorry. Okay, I think it is visible now. Yes. Okay. Okay, I think it is visible. So again, just so here one sample of ANN is given. Okay. So basically in artificial neural network, what is actually happening? It is mimicking the behavior of some noise is there. I think. Okay, fine. Okay. So just I'm talking about the artificial neural network. So one important point is there with respect to ANN. That is, it is mimicking the behavior of human brain, number one. And it is acting as similar to human brain. So in human brain, what is actually happening? Millions of neurons are there, and some of the neurons are there which is responsible for taking the data from body's sensors like ear, nose, eyes, and skin, and just they collect the data and forward that data into the intermediate layers. Some kind of processing is there, and after processing the data, as brain is able to take the decision, similarly ANN is also able to take the decision. So one important fact is there, that is this area is not new. You can say that artificial neural network was invented in 1970s, but it was not so popular till 2005. And the reason behind is that in case of ANN, huge computational power is required. But after introduction of the NVIDIA GPUs, there is no restriction with the ANN. Sorry, there is no restriction with the computational power. So nowadays ANN is too ANN gains too much popularity among the research community, among the industries, and there are lots of applications are there which is based on ANN. Okay, so in ANN, two popular terms are there. One is the, here just you can see that forward propagation and backward propagation. And then later on with the example, we will discuss about how or what is the role of forward propagation and what is the role of backward propagation. So number one, artificial neural network is special type of machine learning algorithm that modeled human brain. Second point is there, that is non-linear statistical models. Okay, so basically in ANN, whatever data you will pass, the model will analyze the data and try to find out the complex relations amongst the input, and based on that relation, model is trying to generate some kind of output. ANN is widely used in image recognition, speech recognition. You can utilize ANN for the machine translation, means language translation, and you can utilize, or you can say that variety of applications are exist which is based on ANN, and that models are utilized by the medical practitioners. And next one is there, one important point, that it learns from the example data set. Okay, so let's say you are working on the classification, then you have to pass the data as well as label, and ANN automatically train itself based on your training data. So here just you can see three popular terms are there. One is the input layer, then hidden layer, and then output layer. So here just you can see this is your input layer where we will pass the feature, and hopefully all of you aware about it. Okay, so I'll take one example of feature. So let's say okay, so suppose you want to predict the price of a house, or prediction of house prices. Okay, prediction of house prices. So it always dependent on the area of the house, number of rooms, okay, city, then locality of the house, then you can say that facility. So all such kind of things act as a feature, because the price of a house is always dependent on these features. Or you can say that these things decide the price of a house. So here, what is the meaning of feature? So basically, features are that entity which provide in against or in favor of the decision. Okay, so let's say number of rooms is 1, then price is low. Number of rooms is 2, then price is high. There is 3, then it is more high. So similarly, means this is the entity which provides a sound impact on the decision. And in this case, suppose you are working on a house prediction model, then these features can provide a sound effect. Sound impact means if you want to calculate the price, then number of rooms is acting as a one of the important entity which decide the price of the house. So this is your input layer. In input layer, we always pass the features, okay? And in lab hour, just you can see, we will work on the image data set, and at there we are using the pixel value as a feature. After then, next point is there, that is the hidden layers, and one is the output layer. So suppose you are working on a classification model, and so classification, two type of classification is there. One is the binary and another one is the multi-class. Okay, so in case of multi-class, so you have to increase the number of nodes. If it is a binary classification, then only one node is sufficient. But if more than 2 classes are there, at that time you have to go with the 3 or more than 3 number of nodes at the output layer. So here just you pass the data. Okay, again there is a connection, and in each connection some weight is there. So here just you can see that your information is processed in each node in the next layer. So here just you can see this kind of connection is there. Whatever the information is kept at here, that information is shared with this node, as well as this node. This node having some information that is shared with this node, and this node. So here you can see that means nodes are connected with each other, and against each connection some weight is there. Okay, so whatever the weight is there, that weight is multiplied with the information stored in the previous node, and just you pass. Now the question is that what is the meaning of training in artificial neural network? So here just you can see this node has some information, let's say x1, we can say that at this node, because wi is there, so x1 multiplied by wi plus some other information. So this, for a short time, just you assume this is the information. Again w2 weight is there, so whatever the information is there, that is multiplied by this weight, and this weight. So this node definitely consists particular information. Okay, let's say capital Xi. So basically this capital Xi is representing the predicted value, and you are working on the labeled data, so you know the actual value. So this model will produce predicted value, you know the actual value. So let's say y is the predicted value, and y cap is the predicted value, and y is the actual value. Okay, so with the help of these two things, you are able to calculate the loss. So you can go with any loss function, and with the help of that loss function, just you calculate the loss. Now, what is our role, or what actually model do? So because you know the actual value, you know the predicted value, based on these two things, you are able to calculate the loss, and your objective is to minimize the loss. And how you can minimize it? So for that, you have to provide the weight values, weight and bias values. So this is the concept. So in short, we can say that in artificial neural network, what actually we are doing, we are trying to optimize the value of weight and bias to minimize the loss. If your loss is minimum, then you are moving towards the good results. So there are two different kind of neural networks are there. Here you can say that one is the feed-forward artificial neural network. So in case of feed-forward, nothing new is there. Information takes place only in one direction. So just you pass the information at here, it pass to the next layer, then next layer, and then at here just you compute the output. Based on the output, you have to update the weight and bias in this direction. Next point is there. So here just you can see the flow of information is from input to the hidden layer and hidden layer to output layer. There is no mechanism, or there is no concept of the feedback loop. And this kind of network is basically used in supervised learning. So what do you mean by the supervised learning? So if suppose you are working in the classification model, then it's a supervised learning. If you are working on the clustering kind of thing, where you want to, you just based on the insight features of the data, and you want to perform or you want to generate the clusters, that comes under the unsupervised learning. So always remember, in case of supervised learning, the label as well as data is there. If label is not there, then you can't say that it is a supervised learning. So I'll take one example. In case of supervised learning, so one model is there and you pass a one image. So digit image. So this is one image, just you pass in the model, and if model provide a answer that the input image belongs to class 1, okay, so your answer is yes, either, or your answer is no. So in case of classification, you always get the answer in the form of yes or no. Let's say one basket is there. In that basket, fruits and vegetables are there. Okay, so many means fruits, vegetables are there. Now, what is your role? Your role is to segregate food and basket. So what you will do based on certain features. Actually, you don't know what is the fruit and what is the vegetable, but after analyzing the features of your data, and you segregate both the things. So that is the clustering. So similar kind of means such item or such data which has similar kind of feature may put in a one place, and similarly just you put other items in the different place. So this is known as clustering. Okay, so similarly one different kind of network is there, that is feedback artificial neural network. So in case of feedback artificial neural network, loops are there. Okay, so here just you can see two neurons are there, and these neurons are actually exchanging the information with each other. So if this is one case, another case is there right here. So loops are there, and if loops are there, then you can say that such kind of network is known as feedback artificial neural network. So such kind of neural network are mainly for memory retention. Okay, so I think I don't know, means all of you know about it or not. In case of language translation, in case of machine translation, language transliteration, and then image captioning, in such kind of problem, whatever network we are using, that is the feedback artificial neural network. Okay, next one is there, one more important point. So these type of networks are most suited for the area where the data is sequential or time dependent. So generally we have the data in form of audio, video, image, text. Okay, so image is fine, because in case of image there is no dependency with the next or previous frame. But in case of weather forecasting data, that is the time series data. So in case of time series data, there is some kind of dependency. If you're talking about the language translation, so one example I'm taking, I'm going to America. So am is dependent on previous word. Okay, going is a verb. Okay, so ing form is there because I have used am. So here just you can see in language such kind of issues are there where some kind of dependency is there with the previous data. So if always remember, if the data belongs to time series category, then you have to go with the feedback artificial neural network. So just I quickly come to the lab, and in between I'll explain whatever content I have covered in the slides. Okay, so all of you please open this link and we go for the lab. And this lab is quite interesting, and it will help you to understand the concept of artificial neural network. So just I'm sharing. Okay, so just I have shared at here. In the chat window, I have shared the link. So all of you just open it and we go for the lab. So this is the Python lab, means whatever the code is there, that is available in the Python. And hopefully all of you know the basics of Python language, number one. And number two, please don't skip any cell. Whatever means we have arranged all the cell in a sequential manner. So don't skip any cell. Otherwise, in the next cell, you will get the error. So all of you just open it, and if anyone is there who is not able to open this lab, so please let me know so that I'll resolve the issue. So already shared this lab in chat window. All of you please open it. Already I think I have shared in the chat window. If it is not there, then just it's very simple. Simple link is there. So what you can do, you can directly open it. I don't think so. So any complexity is there. Okay, just you can see. So tinyurl.com/lab-bu-wsl2. So shall I start? Please, anyone can respond. Means all of you are able to open it or not. Again, I am pasting it. So please check and let me know. In chat window, okay. Okay, fine. So quickly, just we start the lab, and lot of discussion is required in the lab. So just I increase the font size so all of you can see it properly. Okay, so first cell is there. Okay, and in first cell, just we go with the importing of the libraries. Okay, so always remember in Python one you can implement the artificial neural network using TensorFlow, using Keras, with the help of PyCharm, with the help of PyTorch. So all these major libraries are there, which you can utilize for the implementation of the neural network. Okay, so why I'm insisting you to utilize the libraries? So the reason behind is that in these libraries, predefined functions are available, and with the help of that functions, you can write a code in an easy manner. Even though you can implement this neural network in C language, in Java, in C++, Pascal, COBOL, Fortran, anywhere, because it was invented in 1970s, and at that time no Python was there. So only popular language at that time was there, that is C language. So even though you can implement the neural network in C also. So as per your convenience, just you can use it. So first cell I have implemented or executed, you can say that, and there is no problem. So now we can go with the next one. So in next cell, first line is there, batch size. So the why batch size is important, I'll explain in the PPT. Okay, so in batch size, okay. So just you can see, okay. So let's say you have, I'm taking one example of data set named as ImageNet data set. So the size of data set is around 106 GB and 36 GB data is there for the test. So this is for the training purpose and 36 GB data is there for the test purpose. In 106 GB, just you see millions of images are there. Okay, and as all of you having a background of computer science, then all of you know that during the execution, all the related data should be inside the primary memory. But I don't think so. Means any system is having such memory where millions of images can be stored. Okay, I'm talking about the primary memory. So in that case, what we have to do, we have to pass the data in the network in smaller chunks. Okay, so one method is there. What you can do, you can pass, this is your model. For the training purpose, you pass one sample and perform the update the weight and bias. Another method is there, just you pass, if you have sufficient amount of memory, then you can pass 10 lakh of samples, but generally it is not there. Okay, so what is the option? If you go with this one sample in each iteration, then it will take too much time for the optimization. And millions of images already you cannot pass. So what you can do, based on your memory size, you can pass these samples. So either you pass 128 sample or 256 sample or 512, 1024. So based on your memory, you have to define the size of your batch. So the size of batch should be 2 power k form, where k is k greater than or equal to 0. So individual sample you can pass or 1, 2, 4, 8, 16. So based on the memory, you can decide the size of the batch. So batch, this is 1 point, means what is the batch size? Means how many samples you will pass in a single shot. So in our case, batch size equal to 128. Okay, so this is our batch size. Number of classes equal to 10. So I'll explain you on which data set we are working. So right now we are working on the MNIST data set. Okay, MNIST data set. So MNIST data set having, what are the features? So I'll let you know. The size of the image is 28 by 21. Number one, black and white image is there. Black and white. Okay. Number three, 60,000 samples are there for the training. 10,000 samples are there for the testing. And it is handwritten digit. Handwritten digit. So this is, you can say that a major property of our data set. And handwritten digit images are there. So how many images are there or how many digits are there? So digits are 0 to 9. And if you count 0 to 9, then it is 10. So that number of classes equal to 10. So that's why here just you can see it is mentioned that number of classes equal to 10. Now epoch equal to 2. Okay, so just I'll let you know what do you mean by the epoch. So epoch means one neural network is there. Here, just you can see. Okay, and kind of connection is there like this. Okay, just I'm not making all. Okay, okay, then fine. I completed it. So you have passed one batch 1. Okay, at here. Then this is your output layer. Output is checked. Okay, so predicted value, let's say just I passed one sample X, or you can say that this is image of 1. Just you pass it. At the output layer, your model will decide this image belongs to which class with how much probability. Okay, so let's say 90% probability is there. This image belongs to class 1. But actually, this image belongs to class 1. So model should also 100% confident that this image belongs to class 1. It means there is some error. So with the help of predicted value, error is calculated. So error or loss computed. Okay. After computation of the loss, just there is a update in the weight and bias in throughout the network. So sample you have passed in the network, computation of the loss, updation in the weight and bias. This is one epoch. Because this model will run for 2 epoch, then again you have to compute the loss with updated weight and bias. Okay, so definitely there is a change in the loss. As per the loss, again you have to update the weight and bias. This is epoch 2. So in one direction, what actually you are doing, you are computing the loss. Another direction, what you are doing, updating the weight and bias. Okay, so this is one epoch. So one forward movement and one backward movement. So both will make a single epoch. So 2 epoch is there, then you have to update the weight and bias 2 times. Okay, so this is the meaning of epoch. Now next line is there. So in this line, basically our data set is available in the cloud. So after execution of this line, data is divided in 2 parts. One is the test part and train part. So here just you can see 2 things are there with respect to training data. So one is basically holding the data, another one is basically holding the label. Now this in this function, nothing we are doing. So basically the size of the image is 28 by 28. And if you multiply 28 by 28, then that is 784. So actually we have the image. Okay, we have the image and image is in 2 dimension. But now what we are doing, we are converting the 2D matrix into the column vector. And if you convert 28 by 28 in column vector, then 784 values are there, nothing else. So 60,000 for the train, and 10,000 for the test. Here what we are doing, we are only normalizing the data. So because grayscale images are there, so maximum value is 255 of a pixel and minimum value is 0. Okay, so if you divide all the values by 255, then it will lies in between 0 to 1. Okay, so just all of you execute this cell, and as the output you will see 60,000 samples for the training and 10,000 samples for the testing. And this is basically representing the converting the class vector to binary class matrices, which is useful in the computation of the loss. Now we come to the visualization of the data. So what you can do, just you execute this cell, and whatever sample we have passed. So here just you can see y_test 250th position. So whatever the data is stored in the 250th position, that is displayed right here. Even though if you want to change this one 251 to 252, so it will also work. But please do not put a range like 250 to 260. It will not work. So now here just you can see label is 1, image is 1. So here just you can see in your label vector 10 informations are there. Okay, so just you see this image belongs to class 1. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So 10 classes are there starting from 0 to 9, and in the corresponding index value 1 is there. Okay, so suppose here image of 5 is there, then what will happen? 0, 1, 2, 3, 4, 5. At this position, 1 value is there, and in rest of the position, zeros are there. So this is also known as one-hot encoding. Okay, now we come to the model design. So this is the important part. Okay, up to now, if you have any question, then just you leave the message in chat window, and I will cover that one. So during my explanation, I definitely cover your question. Okay, so anyone, if you have any kind of questions or doubt up to this, then just you. So just you type in the chat window. I'm not able to see any question. Yeah, of course, feedback link is there. I don't know why persons are worried about the feedback link. I think based on the feedback, the person will get the certificate. Okay, anyway, if you have any question, so please write in the chat window. Definitely I'll cover it. Okay, fine. So just we are designing a model. Okay, so here just you can see all of you note down or remember it. At the first layer, 32 nodes are there. Okay, and in the next layer again 32 nodes are there, and here also 32 nodes are there. Okay, and at the last, or you can say that output layer, 10 nodes are there. So how I can design it, let's see. So just I'm coming to the PPT part. Okay, so just I make some couple of slides. Okay, so in input layer, you know how many nodes are there? So in input layer, 784 nodes are there. Why 784 nodes? Because we have converted 28 by 28 image into column vector. So if you multiply 28 by 28, then it is equal to 784. So that's why 784 values are there. In the next layer, 32 nodes are there. So 1 to 32. In the next layer, 32 nodes are there. And in the next layer, 32 nodes are there. And in output layer, 10 nodes are there. Okay. And now this is a kind of connection. So all the nodes in the previous layer is connected with each and every node in the next layer. So now you can see this is a kind of network. Okay. So this is your network. So this is your input layer, just I am simulating. This is your output layer, and this is your hidden layer. Okay. In input layer, 784 values are there because each pixel is acting as the feature. Okay, so that's why 784 features are there. At output layer, 10 nodes are there because number of classes equal to 10. This is your architecture. Now on each edge, or you can say that on each connection, some weight is there. And with respect to each node, one bias is there. Okay, so just you can see here how many parameters you have to train. So always remember in ANN this weight and biases are known as trainable parameters. Besides it, some others are also there, but basically these, at least these are there. So how many? So just you can see how many connections are there. So 784 multiplied by 32. You have to update these many weights while you are working only on these two layers. And because 32 bytes are there, so 32. So this is your 25120 parameters you have to train between at here. I'm talking about this to this layer. So at that time, 32 nodes are connected with 32 plus 32 bias. So 1056 parameters are there in this section. Hidden layer 1 and hidden layer 2. Then hidden layer 2 and 3, these many parameters, okay, at here. And at the last, 32 into 10 plus 10 equal to 330. Here it is 1056, 330, and this. And if you sum up it, that is the total number of parameters. So I'll show you in the model summary. So already we have designed a model, and always remember while you are going to design a model, then activation function is also required. And the reason of the activation function, because every time you are not able to separate the data with the help of a straight line or with the help of a line. So to provide the non-linearity in your model, you have to use the activation function. So I'll take one example about the non-linearity. So let's say some data sets are there or some data points like this. So these data points are linearly separable. Okay, so let's say this is a plane. Okay, and if you find the equation of this line, so this line is basically correctly defining the data, or you can say that correctly classifying the data. But sometimes data is like this. Okay, like this. So in this case, what you have to do, if you are able to find a equation of this curve, then you can properly separate the data points. So definitely, I think this is not a line, it's a curve. So if you want to provide the non-linearity in your model, then you have to use the activation function. Some other advantages are also there. So right now we are not going to use that one. So how many means sigmoid is one of the activation function. Beside it, ReLU, leaky ReLU, TANH, sigmoid, softmax, linear. These are other activation function. So each and every activation function has its own advantage and disadvantages. So as per your requirement, you have to use the activation function. So now your model has been built, and just I am running this model. So here just you can see I have computed this number of parameters. So now 25120, then 1056, 1056. So you can see it here. Yes, okay. So in this manner, you can compute the number of parameters. Now, so because in artificial neural network, we started with random weights, then what we can do, just you can see if you will start from the random weights, so random values are there. So definitely in 1 or 2 epochs, you are not able to get the best performance. But in this cell, what we are doing, we are trying to print the value of random weights. So here from this image, you can see that you are not able to see any kind of information. But when you run this model for 2 epoch, and again, if you print the weight value, so right there you can clearly see the difference. So at that time, that weight value or that weights will definitely share some of the information. So previously we defined the structure of the model. After then we have to compile the model. So here in this compilation of the model, you can see loss equal to categorical cross entropy. So this is a loss function. Okay. And we are going to use categorical cross entropy loss function. Beside it, some other loss functions are also there. Anyone means all that loss functions you can find in the Keras library. And as per your choice, you can utilize that one. Optimizer, we are using RMSProp. Beside it, Adam Delta, some other optimizers are also there. So the role of the optimizer is to converge the model quickly. Okay. So actually we are trying to solve the optimization problem. Okay. So why we are solving the optimization problem? So our objective is to minimize the loss by changing the weight and bias. Okay. So if you are going to use the optimizer, then definitely optimizer also help to quickly reach to the convergent point, so that you will save lots of time. Here, the performance evaluation metric is accuracy. Beside it, many accuracy parameter means performance evaluation matrices are there, like precision, recall, phone score, sensitivity, specificity, and then Cohen kappa, AUC, ROC. Many performance evaluation matrices are there. And to study the performance of your model, you can change the performance evaluation matrices. So, okay, we done it. Now, after then, now we have to train the model. So during training of the model, just you can see. So here we go with the 2 epoch, batch size equal to 128. So here just you can see it is written 469 by 469. So anyone can ask means what is this 469? So I'll show you the calculation how 469 is there. So just you can see in training how many samples are there. So 60,000 samples are there. Our batch size is equal to 128. Okay. So if in one batch 128 images are there, then how many batches are there? Okay, so sorry. Okay, so you can see that. Okay, so oh, 150. Some calculation mistake is there, so please check. So just I'm using. Okay, so 60,000 divided by, sorry, divided by 128. So that is 468.75. So that's why what it means. It means in our case 469 batches are there. So when one epoch will complete, so one epoch will complete when all the batch will pass into the model. Okay, and there is a change in the weight and bias, then one epoch will complete. Similarly, in next epoch again we have to pass all the batch in the model, and there is a updation in the weight and bias. So this is our training model training part. Okay, now we come to the next part, that is the testing. Okay, so during testing what actually will happen, whatever the tested data we have defined, that data is passed in the model, and it will check the accuracy, test accuracy. So just I'm changing the verbose, and here just you can see. Okay, so again Y313 is there. So how many samples are there? 128. Sorry, batch size is 128. Okay, 313. Okay, fine. Now, I think previously we checked that random weights. Now you see after training, there is lots of change in the weight images. Now you can see. Okay, so I think these images are better than the previous one. Now anyone can ask how you have created these images. So the very fundamental or very simple concept is there. I'll show you in this slide. So basically, number one, so this is the visualization of the first layer. And if you see how many images are there, so 1, 2, 3, 4, 5, 6, 7, 8. And 8, next plus 8, plus 8, plus 8. So total 32 images are there. And this is the weight visualization of the first layer. So just you see in the model, okay, Okay, so at this layer, 32 nodes are there, and in each node, 784 connections are there. It means in each node, 32 incoming edges are there. So each is having some weight value. So what we did, we simply converted the 784 values into matrix form. So if we convert this 784 into the matrix, then 28 by 20 is there, and converted this matrix in form of the image. So whatever image you are able to see at here in the notebook, in this manner we have generated. Okay, so what we did up to now, so we build a model, we compile the model, we train the model, we test the model. Now we are moving towards the prediction. Okay, so here just you can see we simply pass one image for the prediction purpose. So let's say here 23:24 is there. Now I'm converting it 1113 to 114. Okay, and just you check it. So basically for this sample, our model is predicting the class 0, 1, 2, 3, 4, 5. Our model is showing that whatever the sample you have passed, that belongs to class 5. And what is the probability? So you can compute the probable score, that is 0, 1, 2, 3, 4, and 5. So here just you can see what it means. 88% probability is there. Whatever sample you have passed in the model for the prediction purpose, that belongs to class 5. It is the meaning from this cell. Okay, and always remember, if you sum up all these values, so that is equal to 1. Now anyone can ask question. What the question? Because here just you can see the image belongs to class 5, but some similarity is there with respect to class 0, class 1, class 2, class 3, class 4, class 9. Okay, what it means, with respect to every other class, some similarity is there. The similarity may be low, but similarity is there. So yes, of course, it is possible. Just I am taking the help of slide to explain this concept. Okay, so just I'm talking about, let's say 5. Okay, so this is the image of 5. You see this is 0, but if you see this section and this section is matching. If you take 2, so this section is matched with this one. If you take 1, so it match at here. If you take 9, so yes, again some similarity is there, this section and this section. If you take 3, so this and this is matched with this section. If you take 6, so this is matched at here. So yeah, of course, it's a digit. Okay, and definitely some matching is there. So that's why, because for in each class, in the sample of each class, there is some portion or some small or high portion is there which is matched with each other. That's why we are getting some small score with respect to each class. So here we have passed this 1113:1114 number sample. Now just what we can do, we can check this same sample. Just we are trying to print that whatever prediction is there, that is actually true or not. Okay, so just I simply run it. Oh, so it is the image of class 5, and our model also predicted it 5. Now we come to the next part. Let's say user defined data. Okay, so means data, anyone or in this situation what you can do, anyone can upload the data, okay, in the Azure notebook, and just you put the name digit.jpg. If you don't want to execute this line, you want to work with your own image, then what you can do, you can upload the data and you call that one. So because this data, so here first we just see what kind of image is there, and according to that image we have to provide some kind of reprocessing. So this is a colored image, size of the image is 397 by 397. Then first of all, if we want to pass this image in our model, then we have to convert this colored image into black and white image, number one. And number two, we have to resize it because our model is taking an image of size 28 by 28. So we have to resize this image into 28 by 28. So just we have resized it. Now, what we are doing actually, now we pass this image in the model. And here just you can see model is predicting the input image. Okay, the input image belongs to class 3. Okay, and definitely in this cell, I think some of you will get the error. The reason behind is that if the accuracy of your model is not appropriate, let's say it's less than 50%, at that time definitely you will get the error. So if anyone is getting the error, then just let me know. So I will suggest a couple of changes in this cell and it will work fine. So anyone who is getting the error or anyone who is having any kind of questions, doubt, so simply just you write in the chat window so that I will cover that one. So anyone having any question or any doubt, so please write in the chat window. Okay, so anyone, if you have any question, then please write. Hello.
Yeah, participants, any doubts?
Okay.
Sir, feedback. Participants, dear participants.
No, madam.
Oh,
Yes, ma'am. Abhi,
yeah,
yes,
yeah.
I
Okay,
didn't
okay, sir.
complete. I didn't complete the whole
Oh, yeah,
session.
yeah. Okay, sir. Please continue the session, sir.
Okay.
I
So
thought that
if anyone has any doubt, then just let me know. Otherwise, I'll move forward
you
because.
can move, sir.
Okay, fine, fine. And because please, all of you just do it parallelly because at the last couple of exercises are there, and you have to do that one. Otherwise, the certificate will not be issued. So, ma'am, those who will not complete that exercise, please don't share the feedback link with them. Okay. So just I'm kidding. No problem. So this is prediction. Now the next part is very much important. Just you can see. So saving, loading, and retraining the models. So actually, what happened? Let's say you build a model in your laptop or computer. Now you want to utilize that model in Raspberry Pi. Okay, so in Raspberry Pi, how you can utilize it? So in that case, what you have to do, you have to save the model. So while you are going to save the model, two files are there. One is the weight file, another one is the architecture file. So if you have these two files, so with the help of these two files, you can deploy the model in any other device. So here just you can see, suppose you want to save the model. So 3 line of code is there, nothing else. So just you can see it here as JSON file, JSON underscore file dot write. JSON stands for JavaScript object notation. Okay, so JSON file you have to write, and next one is there that you have to save the weight, and weights are saved in the model.h5 file. So now you have saved the model, you have saved the weight. Now what is the next turn? So next turn is there, that is loading a model. Now you want to load the model. So suppose you want to load the model, then what you have to execute, just you can see, it's a predefined code and fixed code. With the help of this code, you can load any model. After then, if you want to retrain the model, so at that time, what you have to do, whatever model you have loaded, in that model you have to pass couple of parameters, and you can retrain the model. So if you remember previously, we have executed or we have trained our model for the 2 epoch, and in this time again we are training the model for the 2 epoch, and you can see previously our accuracy was started at 40%, 40 or 44%, and ended at 80, I think 88%. Now, after completion of the 1 epoch, during retraining, the accuracy is 89%, and after 2 epoch, accuracy is 92%. Okay, so why it is there? Because you are retraining the model. Already model has been trained, but again you are retraining, so that's why it will start from the previous state. So that's why it is 92%. Again we come to the next part, so part 3. So here just you can see, okay, complete code is there, but here we have used linear activation function. So just I change the linear activation function. Then next one is there, Now in this cell, you have to write the code using ReLU activation function. So all of you please write the code at here using ReLU activation function. And next model with low number of nodes. Okay, so we have designed a model. At the first layer only 8 nodes are there. So this model is given. Just you try to provide the change in the model. Then design a model with higher number of nodes. So at this cell, all of you write a code. Okay, and similarly, lower number of layers, you see. Okay, we one code is there. Just you reduce the number of layers in that model. Then only 4 hidden layers. You write the code here. Just you see one more code. Okay, so have new image is there, and just you have to test this image. Just you have to test this image. Okay, so now you can see means after completion of this lab notebook, what you are able to do, you are able to design a artificial neural network model for the image classification. Okay, you can add, reduce the layers or number of hidden units. You can practice with by changing the activation function and see any kind of change in the performance is there or not. Okay, just all of you try with some different optimizers. So all such kind of practice, if you want to do, this lab notebook is sufficient. And if you complete or if you completely understand this notebook, then you are able to build a ANN model for the image classification. So I would suggest all of you repeat all the exercises available in this lab notebook. Then you are means you will have a good confidence while you are working with the ANN in later stage. So this is all about me and my lab. Okay, if you have any question, then just share with me so that I will provide the solution. And if you have any other kind of doubt, then you can also ask to me, and if possible, I'll try to provide the answer.
Sir Gupta, sir.
Yes, yes. Oh, yes, ma'am.
Yes, sir. How much time, sir? How much time it will take, sir?
No, I'm done. So already some exercises are there. So I would suggest if the participant will practice that exercise, because I'm available for 10-15 minutes, and if they will have any doubt or any question, then I can resolve it.
Okay, sir. Okay, okay. Participants, dear participants, any doubts, please? Sir.
Devakishan sir, something you are. Devakishan sir. Sir, speaker is waiting for your queries. Still, anyone having any questions, please? Yeah. Feedback form. Session 4 feedback form. Ujjwala madam, no sir. Thank you, Ujjwala madam. Nagarama Devi, nice session, sir. Right. Thank you, Rama Devi madam. Any suggestions or any clarifications or any doubts, please? And one already feedback form is pasted in a chat box. Please fill the feedback and then leave the session. Sir, shall we leave the session, sir? Sunit Gupta, sir.
Yes, from my side, it is over.
Thank
So
you.
if,
Yeah, thank you very much, sir.
If anyone has any doubt, then I can
Yeah.
attend this, no problem.
Yes, sir. Shall we wind up, sir?
Yeah, we can.
Okay, sir. Thank you. Shanti
Okay.
madam.
Okay, thank you.
Okay, sir. Okay, thank you all.
Something wrong, net problem. Yeah, and the participants, those who are completed your feedback, please leave the session. So I think still 21 members for that. Just click, sir, Vijay sir. Thank you, sir. Thank you for joining. Malareddy Engineering College, Vijay sir. Malareddy Engineering College. Madam, KPRIT, Apanalakshmi, thank you, madam. Thank you for joining. Ashwini Gaur, Radhika, Chinna, Sudha, Narsimachari, please, sir. Once you fill the one software, sir. Madam. Yeah, Shashidhar, sir. This is a feedback link. Once you click on it, Shashidhar, sir, are you there? Shashidhar, sir. Shashidhar, sir, are you there? Sir, I sent a feedback form link. Once you click on it, right? Thank you all. Thank you very much. So with your permission, just I'm closing this meeting. Navya, Anuradha, Lakshmi Prasanna, MGH Nazia, Srinivas. Sir, leave the session, sir. Once you complete your feedback form, please leave the session. Right. I'm closing the meeting, sir. Thank you very much. Thank you for all. Tomorrow, who can join shortly.